Protected topics for Paper 2, Edexcel IGCSE Chemistry Exam 2024. Topic 1 is solubility and solubility curve. Remember that solubility is the amount of substance in gram that completely dissolves in 100 gram of a solvent. So it's a gram per 100 gram. Solubility changes with increased temperature. It could increase or decrease. And you should be able to interpret data from solubility curve in your exam. Ionic bonding, remember that ionic compounds have giant ionic lattice and there is strong electrostatic interaction between the oppositely charged ion. This is why they have high melting point and they cannot conduct electricity as solids as there are no free ions to move. They are held in the giant lattice and they can conduct electricity when molten or when dissolved because ions are now free to move and carry the charge. Metallic bonding. Metallic bonding is found in metal. It's a strong bond, comes from the electrostatic interaction between negatively charged delocalized electrons and positively charged ions. You should be able to explain the typical properties of metals like electrical conductivity and malleability. Remember that the free delocalized electrons that move through the structure can carry the charge. This is why metals are able to conduct electricity and because they have regular arrangement of layers and these layers can slide past each other when hammered, then that means this is why they are malleable. Electrolysis, remember that electrolysis is split by electricity, and in electrolysis we have an electrolyte, we have two electrodes, the cathode which is the negative electrode and the anode which is the positive electrode, and we have an electrical current source. When electrolysis takes place, the positively charged ions will travel toward the cathode where they are reduced as they gain electrons, and the negatively charged ions will travel toward the anode or the positive electrode and they lose electrons so they become oxidized. Electrolysis only occur either in molten ionic compounds or in aqueous solution. So electrolysis of molten ionic compound, something like molten sodium chloride, we have the positive ions are reduced to the element at the cathode and this is the ionic equation for the reduction of sodium ion to give you sodium. And the negative ions are oxidized at the anode. So this is the ionic equation for the oxidation of the chloride atom ion to give you chlorine and the electrons. Electrolysis of aqueous solution is a different story because in case of aqueous solution we have competition at both the cathode and the anode. So at the cathode or the negative electrode there will be competition between the metal ion and the hydrogen ion that comes from water. The metal above if the metal is above hydrogen in their activity series, then hydrogen ion is the one that is going to be reduced to give you hydrogen gas and you will see bubbling there. Metals below hydrogen in the series, the metal itself will be reduced to give you the metal at the cathode. At the anode or the positive electrode, there will be also competition between the anion and the hydroxide ion that comes from water. So only halides will always be oxidized to give you halogens. However, if you have any other anion like nitrate or sulfate or any other thing other than the halides, then the hydroxide ion is the one that is going to be oxidized to give you the oxygen. Reactivity trend and the periodic table, you should be able to explain how group 1 elements reactivity increases as you go down the group. The outer shell electrons becomes further away from the positively charged nucleus, so it becomes easier for the element to lose electrons. Explain how group 7 elements reactivity decreases as you go down the group. It's the opposite to group 1. Again, this is because of the same reason. The outer shell electrons become further away from the positively charged nucleus, so it becomes harder for the element to gain electron to give you the negatively charged ions. Reactivity series and extraction of metal. This is the reactivity series. You should pay attention to the position of carbon here in the reactivity series. Remember that metals below carbon in the reactivity series up until copper, they can be extracted from their ores using carbon. Carbon is more reactive than these metals, and it acts here as a reducing agent where it takes the oxygen from the metal ore, which is oxides of the metal, or it actually as well we can say it's a reducing agent because it gets oxidized and it loses electrons. Metals above carbon in the reactivity series, which are these metals, these are group 1, 2, and 3 metals. They are more reactive than carbon and they can be extracted from their own ores using electrolysis. Very unreactive metals at the bottom of the reactivity series, silver, gold, and platinum, are found as uncombined elements. Uses of metal. Remember that copper is used in wiring, not only because it can conduct electricity, but also because it has lower resistance, and it can be used in heating systems because it can conduct heat. Iron corrodes easily, and adding another element to iron to make alloys changed its property. So you should know about low carbon steel, which is easily shaped. High carbon steel is strong and inflexible. Stainless steel is corrosion resistant. Aluminium doesn't corrode. This is because of the layer of aluminium oxides, and it acts as a protective layer for aluminium to prevent its further corrosion. Acid-base titration is a very, very common topic in your exam. You should be able to carry out acid-base titration because could ask you to plan an experiment to carry out acid-base titration. You should know your indicators very well and the color change in acidic and alkaline solutions. And you should be able to improve a titration method provided to you in the exam. Topic 8 is energy level diagram and calculation of enthalpy using bond energy. Remember the difference between exothermic and endothermic reaction. It's almost certain that in the exam they will ask you to draw the energy level diagram for either an endothermic or exothermic reaction. Remember that in exothermic reaction, reactants energy are more than the energy of the product. The activation energy is the difference between the energy of the reactants and the top of the diagram, and the overall energy change or the enthalpy is the difference between the energy of the reactants and the product. Remember that the exothermic reaction releases energy or releases heat. There is an increase in the temperature, and the overall energy change value will be negative. Endothermic reaction, reactant energies in this case will be lower than the product energy. The product energy will be higher. Activation energy again is the same difference between reactants and the top of the diagram, and the overall energy change or the enthalpy is the difference between the energy of reactants and products. The reaction here will take in energy, so there will be a decrease in the temperature. The overall energy change will have a positive value. Delta H or the enthalpy can be calculated from bond energies, and they could provide you with the bond energy of different of all the reactants and products and ask you to calculate the enthalpy. Remember that the delta H equals the energy gained to when breaking bonds and reactants minus the energy lost when making bonds and product. So it's going to be a negative value for exothermic reaction and a positive value for endothermic reactions. Reversible reactions and position of equilibrium. You should be able to know what is meant by equilibrium and when equilibrium is reached. You should know the factors that affect the position of equilibrium. These are the temperature, which depends on which way or which direction is exothermic and which one is endothermic, concentration in case of solutions only, and pressure in case of gases only, and the pressure will depend on the number of moles of reactants and the number of moles of products. The use of catalyst, remember that the use of catalyst will not affect the position of equilibrium because a catalyst will increase the rate of the reaction in both directions at the same rate. Topic 10 is organic chemistry. The topics that will most probably feature in your exams are alcohol, carboxylic acids, and esters because hydrocarbons usually come in paper 1. So you should know the different ways of manufacturing ethanol. First one is the fermentation of glucose to give ethanol. So glucose gives you ethanol and carbon dioxide. You should know the products and you should know the optimum condition, which is a temperature of 30 degrees and under anaerobic conditions or in the absence of air to prevent the further oxidation of ethanol to ethanoic acid. Also, heating ethene with phosphoric acid catalyst at a temperature above 300 degrees and a pressure between 60 and 70 atmosphere. Remember that different ways of oxidizing ethanol are burning in air or oxygen. This is complete combustion that will give you carbon dioxide and water. Reaction with oxygen and air to give ethanoic acid. This is microbial oxidation. And heating with potassium dichromate and dilute sulfuric acid that will give you ethanoic acid as well. You should know the structure formula of carboxylic acid functional group. This is the functional group of carboxylic acids. And you should know the reaction of carboxylic acid with metals and with carbonate. Remember, carboxylic acid with metal will give you salt of the carboxylic acid and hydrogen, while with carbonate will give you the salt of the carboxylic acid, carbon dioxide, and water. You should know that the reaction between a carboxylic acid and alcohol will give you ester. This is the functional group for the ester, where the carbonyl group or this group comes from the acid, the oxygen comes from the alcohol. You should be able to name the ester produced. Remember that the ester has two parts. The first part comes from the alcohol, which is the part here attached to the oxygen, and the second part comes from the carboxylic acid, which is going to be that part here. And remember that this carbon is part of the carboxylic acid. So when you count the number of carbon atoms, don't forget to count this carbon as well with it. Esters are volatiles with distinctive smells. This is why they are used to make perfumes. Topic 11 from organic chemistry as well is condensation polymerization. So you should be able to write the structure and displayed formula for polyester. Polyester is a condensation polymerization product, comes from the reaction between a dicarboxylic acid and a diol. This is the reaction between ethane diodic acid and ethane diol, where ethane diodic acid is a dicarboxylic acid, two carboxylic acid groups here, and the ethane diol has two OH groups here, or two hydroxyl group, and ester is formed here by the removal of an OH and hydrogen from the alcohol to give water molecule to give you the final product, which is the ester. That will be the repeating units here. This is the repeating unit here. And remember that there is molecules of water are also produced from that reaction. You should be able to identify the repeating unit of any polymer. And remember that some polyesters, which are called biopolyesters, are biodegradable. Topic 12 is making soluble salts. You should be able to make soluble salt starting from an acid and insoluble base. And when you do so, remember that the insoluble, you add excess of the insoluble base and then you filter the excess. And then the filtrate undergoes crystallization to give you the crystals of the pure soluble salt, which you can then dry to get the pure dry soluble salt. You can also make soluble salts starting from two soluble reactants through precipitation. For example, lead sulfate, it's a precipitate, it's insoluble in water. You can form this by a reaction between lead nitrate and magnesium sulfate. That will give you a precipitate or a solid of lead sulfate, and you can filter the lead sulfate and then dry it. Remember the rules for solubility of different salts. So all salts of sodium, potassium, and ammonium are soluble in water. All nitrates are soluble. Chlorides, all soluble except silver chloride and lead chloride. Sulfates are soluble except lead sulfate, barium sulfate, and calcium sulfate. Carbonates are all insoluble except sodium, potassium, and ammonium. Remember that we said sodium, potassium, and ammonium, all their salts are soluble. Hydroxides are all insoluble except sodium, potassium, and calcium. And finally, the equations that you will need for your reaction. There will be several equations or several math questions in your reaction where they're going to ask you to calculate the concentration of from titration, or they could ask you the volume of a gas. So these are the equations that you need. Remember how to calculate the number of moles using the mass of the substance over the formula mass or relative atomic mass if it's an element. And remember that the volume, to calculate the volume of a gas in decimeter cube, that will be the number of moles of the gas times 24. You can get the number of moles by dividing mass of the gas in gram over the formula mass of the gas. Remember that 1 mole of any gas occupies 24 decimeter cube. Remember the percentage yield, it's the mass of the product that is actually made over the maximum theoretical mass of the product times 100. And remember how to calculate the concentration in gram per decimeter cube. This is the mass of the solute in gram over the volume of the solvent in decimeter cube. Remember that usually in the exam, they're gonna give you the volume in centimeter cube. So don't forget to divide this by 1,000 to change it into decimeter cube. Also, there's concentration in mole per decimeter cube. It's the number of moles of the solute over the volume of the solvent in decimeter cube. Remember these two triangles. So the first one is when you try to get the number of moles from the mass and the molecular formula mass. Or if you want to get the mass, you have the formula mass and you have the number of moles, and you want to get the mass of your substance. So you can use this triangle. Also, how to calculate the concentrations from the moles and volume, or they could ask you to calculate the volume, to calculate the number of moles from the concentration and volume. So number of moles equals concentration times volume. Remember that the concentration is usually in mole in decimeter cube, and the volume has to be in decimeter cubed as well. In the exam again, they're going to give you the volume in centimeter cube, so don't forget to change that into decimeter cube by dividing by 1,000.